For this video, you're going to want to refer to your unit circle. So if you don't have it in front of you, pause the video, grab that, pull it up either through Google Drive or online. I did give out hard copies in class, so just make sure you got a copy and pause the video while you grab that. On your unit circle, to sketch the graph of y equals tangent theta, we're going to look at quadrants, and since tangent is y over x, we're going to use all of that information to start sketching the graph of tangent. All right, so go to 0 degrees or 0 radians on your unit circle. You'll find the point 1, 0. So y divided by x, 0 divided by 1 is 0. So at angle 0, tangent is 0. Work your way up to pi over 4. The x and y coordinates are identical, so those are going to divide out to 1. And so you've got the point pi over 4 and 1. Now, as you work your way up to pi over 2, now directly at pi over 2, tangent's undefined because 1 divided by 0 is undefined. But as you work your way up, y values get larger and larger while x values get smaller and smaller. So your y over x ratio will get super large. Now, once you're at pi over 2, you have the point 0, 1. 1 over 0 is undefined, so we have a vertical asymptote. Keep going. After you get past pi over 2, you're in quadrant 2. In quadrant 2, your y's are positive, but your x's are negative. And look at the points on your unit circle, and you can verify that. The y's are really positive, and the x's are really small and negative. So that ratio is negative infinity. Think of it also, if you were to go to 91 degrees, it has a negative slope, but it is super steep. As you work your way around quadrant 2, you'll find 3 pi over 4. That y over x ratio is negative 1, so you get this point at negative 1 for the angle 3 pi over 4. And then when you finally make it to pi, you have the point negative 1, 0. 0 divided by negative 1 is 0. And so tangent continually oscillates in these streak patterns. It's all based on y to x ratio and slope of the angle you're looking at. At vertical angles like pi over 2, 3 pi over 2, which are 90 degrees and 270 degrees, a vertical angle has an undefined tangent or an undefined slope because you're going to divide by an x coordinate that's 0. Notice that with tangent, the streak only has a horizontal distance of pi units to complete itself. On the unit circle, every time you make a pi radian sweep or a sweep of 180 degrees, your slopes start repeating themselves. So tangent has a period of pi. The easiest way to mark that is between the asymptotes. It's pi units between the asymptotes, so that's the period for tangent. Let's discuss the domain and range of tangent. Tangent can take any angle as long as it's not a vertical angle, like pi over 2 or 3 pi over 2. If you avoid those angles, then any other angle you pick, you can get a whole range of values, larger, smaller. For example, if you were to type in, say you're in degree mode, and you were to type in tangent of 75 degrees, hit enter, type in tangent of 85 degrees, hit enter, and then say you even went farther and went tangent of 89.9 degrees, those answers are big and they continually get larger and larger. And that explains this streak towards infinity. The closer you get to 90 degrees, on the 80-something side of it, the larger your tangent answer is. Now, once you break the 90-degree threshold, say you typed in tangent of 91 degrees, you're going to get an extremely negative answer. And that's why once you get past this asymptote, the y's turn into really negative values. The domain is all angles except for these odd pi over 2, and we've discussed that on a previous video, odd pi over 2 multiples. The range is infinite because there's no restriction to how large or small your tangent value is. So here's the domain and range of tangent. Domain is any angle such that the angle is not an odd multiple of pi over 2, and n is any integer. The range, unlimited. Tangent has no amplitude because there's no max or min to take half of the difference of. This one is in your Google Drive folder. This is week 6, dated February 18th of 2022. Basically, and if you want to, you can just look this chart up as well. But anyway, it's a summary chart of all your trig functions and their graphs. Sorry to make that move around so much. It discusses the basic shape of one cycle or a couple cycles. Domain range, even versus odd. We'll discuss that in a little bit. And asymptotes, the period, the x-intercepts or zeros. So I'm going to go ahead. You can pause this, take a picture of it, or write them all down if you like. I'm going to go ahead and move to the next slide. Even functions are symmetric with the y-axis. If you fold the graph like a book using the y-axis as the spine, your graphs will match on each side. Cosine and secant are even functions. If we take the graph of cosine, crease at the y-axis, and if you were to fold the right side over onto the left side, essentially closing the book, both sides would touch perfectly. Mathematically, for an even function, cosine of a negative angle is identical to cosine of that positive angle. For example, cosine of negative pi over 2 is 0. Cosine of positive pi over 2 is also 0. Cosine of negative pi is negative 1. Cosine of positive pi is also negative 1. So no matter which angle you pick, if you pick a negative angle, its positive cousin will have the same cosine value. Same thing for secant. Pick a negative angle and then change it to a positive, you've got the same y value or function value, and that's true for secant. Secant of negative pi is equal to secant of positive pi. Again, crease at the y-axis, close it like a book. The left sides and right sides lay on top of each other perfectly. Odd functions are symmetric with the origin. If you spin the graphs upside down, they look the same as they did right side up. The other 4 trig functions are all odd. Mathematically, what that means is sine of a negative angle is equal to negative of sine of its positive cousin. For example, if I pick on negative pi over 2 and positive pi over 2, sine of negative pi over 2 is negative 1. Sine of positive pi over 2 is positive 1. So switching signs switches you the sign of your answer. And that's true for all 4 of these trig functions. Tangent also works the same way. If you pick, now in class what I did was I highlighted these graphs turned them upside down, they look the same. And that's a characteristic of an odd function. It's symmetric with the origin. With tangent, say I pick pi, negative pi, those are the same values. If I pick this value and that value, like negative pi over 4, positive pi over 4, tangent of negative pi over 4 is negative 1. Tangent of positive pi over 4 is positive 1. So you switch the sign of the angle, you switch the sign of your answer, basically. I hope this video's helped. If you have any questions, reach out by phone or email, ask in class, and I'll do my best to help you out.